Okay, today we are diving into a really clever web attack, one that feels almost like a magic trick. We're talking about a high-tech heist that can steal your data without ever running a single line of malicious code. So, how on earth is that even possible?
Yeah, I know it sounds completely impossible, right? We're always told that hackers need to run scripts or malware or something. But what if they could just trick your own browser into handing over the keys to the kingdom? That's the big mystery we're going to unpack today. How do you pull off a data heist with no code, just a few cleverly misplaced characters?
So let's start our investigation into this scriptless heist. First, we'll look at how websites are supposed to be protected. You know, the digital fortress. And then we'll find the tiny little crack in the wall that lets the thief slip right through.
Think about a modern website like it's a bank vault. It's got all these layers of security. One of the biggest defenses is called a Content Security Policy, or CSP. You can just think of it as a really strict bouncer at a club. It has a list of approved guests, like scripts and images, and it blocks absolutely anything that's not on that list from getting in.
But see, here's the critical weakness. All these powerful defenses, they're laser-focused on stopping one very specific threat: rogue JavaScript. The attack we're looking at today doesn't use any JavaScript at all. It's like a ghost that can walk right past the guards because they're simply looking for the wrong kind of intruder.
So how does this attack actually work in practice? Let's follow the breadcrumbs and break down the anatomy of this heist, piece by piece. We're going to trace the path of a single stolen piece of data, something called a CSRF token. That's just a unique secret code a website uses to make sure that actions, like, say, changing your password, are really coming from you.
The whole operation boils down to three surprisingly simple stages. First, the attacker finds a vulnerable spot. Second, they craft a very specific broken little piece of code. And third, they just sit back and wait for the data to be delivered right to their server. It's actually kind of elegant in its simplicity.
So, step one is all about reconnaissance. The attacker looks for a weak point, usually something like a search bar or a comment field, where whatever they type in gets displayed or reflected right back on the page. The absolute perfect spot is one that's right next to something valuable, like that hidden token that's supposed to be proving you are who you say you are.
And this is the weapon. It's not some complex script, it's just a tiny fragment of an image tag. But look closely. It starts with a couple of characters designed to break out of whatever HTML element it's in, and then it starts a new image tag. But it never finishes it. That single quote at the very end is left open on purpose. It's left dangling.
And right here, you can see exactly how the hijack happens. Check out the resulting code down at the bottom. Because the attacker's SRC attribute was left open with that dangling quote, the browser gets all confused. It just scoops up everything that comes after it, including the entire hidden input field with our secret token, and it treats all of it as part of the image's web address.
Now this is the really crucial part. The browser isn't being malicious, it's just trying to be helpful. It sees what it thinks is a broken image link and it does its best to try and fix it. That helpful behavior is the exact thing the attacker is exploiting. The browser itself becomes an unwilling accomplice in the crime.
And finally, the trap is sprung. The browser tries to load this Frankenstein of an image by sending a request to the attacker's server. But guess what? The URL for that image now contains the victim's secret token. The attacker doesn't have to break in. The data is delivered right to their doorstep, captured perfectly in their server logs. Heist complete.
So that's the how. But to really get this, we need to ask why. Why would a browser ever behave this way? Well, the answer goes all the way back to the early days of the internet, to a design choice you could almost call the web's original sin.
Back in the 90s, when people were first building websites, a lot of the code was, well, it was messy. It was full of errors. So the people making browsers decided to be forgiving. Instead of just showing a big error page for broken HTML, they tried their best to guess what the developer meant and just render the page anyway. This is called error tolerance.
And there you have it. A feature that was designed for usability, to be graceful, becomes the very vulnerability the attacker uses against us. They aren't exploiting a bug in the code, they're exploiting a fundamental, intentional design principle of the web itself.
Okay, so now that we understand that root cause, let's connect the dots. We can see exactly why this dangling markup attack is so darn effective at bypassing those modern security fortresses we were talking about earlier. Just look at this comparison. A content security policy, that digital bouncer, will almost always spot an unauthorized script tag and block it immediately.
But an image tag? Most security policies let images load from other domains because that's just how a lot of the web works. The payload slips right past the guards because it's disguised as totally legitimate content.
And it's not just about images. Attackers can use this same dangling technique on all sorts of HTML tags that make requests out to the internet. They can hijack forms, they can change the base URL for every single link on a page, they can even use CSS rules to leak data. It is a surprisingly versatile technique.
So what's the bottom line? Why should you care about this? Well, with this technique, attackers can steal everything from those secret tokens they need to take over your account to your private messages, personal information, and even secret API keys that might be embedded in the page. The impact can be absolutely devastating.
Okay, I know this sounds pretty scary, but it's not hopeless. There is a way to defend against this scriptless heist. And the solution is really more about discipline than it is about some fancy new technology.
You see, the key isn't to play whack-a-mole, trying to block every possible tag an attacker might dream up. The real solution is to focus on the source of the problem: untrusted user input. The unbreakable rule is to never, ever trust data that comes from a user, and to sanitize it before it ever even touches your HTML.
So a really robust defense needs multiple layers. First, and this is the most important one, is output encoding. That just means converting special characters like quotes and angle brackets into harmless versions so they can't break out of your HTML. Second, you validate your input so you're only allowing the characters you expect. And third, having a restrictive content security policy that, for example, only allows midges from your own domain can act as a fantastic safety net.
And you don't have to take my word for it. This quote from the security experts at Portswigger really drives the point home. The good news is, if you're already doing the right things to prevent classic cross-site scripting, that's when attackers inject actual malicious scripts, then you're already most of the way to preventing dangling markup too. It all comes down to the same core principle: good data hygiene.
So that's where we'll end it. We've seen how a feature designed to make the web more robust and user-friendly, error tolerance, also created this subtle but incredibly powerful vulnerability. And it leaves us with a pretty fascinating question. As we keep building on top of these decades-old foundations, what other helpful features of the web are just sitting there, waiting to be turned against us?